This is the Lubben method for finding the cross product. This will not find the magnitude of the cross product, but it will find the actual vector of the cross product. Suppose you have two vectors, A and B, as I have here, and the cross product only works in 3 dimensions. So you have 2i, vector A is 2i plus j minus k, and vector B is minus 3i plus 4j plus k. So let's write out the determinant. And so I'm going to put I here, j here, k here, and I'm going to put vector A here and vector B here. Okay, and we are finding A cross B. So the first vector A is going to go here, and the second vector B is going to go here. Now take these first two columns, I and j, and rewrite them here. And I get a 2, negative 3, and I get a 1, 4. Now, going from left to right, top to bottom, look at these 3 diagonals. Those are going to be positives. So I'm going to have 1 times 1 in the I direction, plus negative 1 times negative 3 in the j direction, plus 2 times 4 in the k direction. Then let's go bottom to top, left to right. Okay, so these are going to be minuses. So I'm going to have a minus 1 times negative 3 in the k direction. Negative 3, 1. I have a 4 times negative 1, so that's a minus 4 times negative 1 in the I direction. And then a minus 2 times 1 in the j direction. So the trick is top to bottom, left to right are positives, and then left to right, bottom to top are negatives. Now we need to just add up all of our components here. So if we add up the I components, I'm going to get an I plus 4i. Okay, negative times negative is positive. So I'm going to get a 5i. And let's do the j's. I'm going to get a positive 3j and a minus 2j. So that's going to be a positive 1j. And then I'm going to get an 8k plus 3k. And that's going to be an 11k. So A cross B, you remember your cross product gives you a vector, is going to be 5i plus j plus 11k. Now, the magnitude of this, the magnitude of A cross B, well, you could do it 2 ways. Remember, it would be the magnitude of A times the magnitude of B times the sine of the angle between the two. So the magnitude, but that's also equal to, we can do Pythagorean's theorem here, 5 squared plus 1 squared plus 11 squared. Whatever that comes out to be. Those are equal.